Pre-placed reinforcement glass fiber composites are the material of choice in structure-critical applications, such as in high-performance automobiles, aerospace, the defense industry, and other critical composite applications. And sheet-molded composite, a flowed compound, has been the material of choice in high-volume, low-cost manufacturing applications, particularly in the automotive and truck industries. So what do you do when you've got a high-volume application and need the cost and volume benefit of flowed compound combined with the superior structural efficiency of pre-placed reinforcement? The answer is clear. The solution is Prime. I'm Peter Emmerich, Vice President of Technology at Molded Fiberglass Companies, and I'd like to introduce you to Prime, pre-positioned reinforcement ensuring manufacturing excellence. Prime is mainstream. It's the best of both worlds. It gives high-volume manufacturers the low-cost economics they've come to expect from SMC, while providing the mechanical benefits of aerospace technology that their parts require.
Prime is mainstream because of all the processes, and there are many, such as pultrusion, open molding, wet molding, filament winding, process like these. The reinforcements are pre-placed on the mold, and the resin matrix is added. So it is mainstream. It's just that there are different variations of how to do that. Prime is one variation of doing that, one way of doing it for structural, high-volume commercial applications.
SMC or Prime? Which composite solution is right for you? It all depends on your volume, the part complexity, and the structural requirements. Most low to medium volume, critical composites applications allow the use of pre-placed oriented fibers for reinforcement. Knowing where the fibers are provides the assurance that each part meets the design intent. An advantage of pre-placed reinforcement is that the fibers can be aligned with the load set, resulting in the optimum fiber efficiency and the lowest possible weight. Pre-placed reinforcement has historically been the preferred choice for all critical composite applications, such as airframes and control surfaces for commercial aircraft, ballistic armor for personnel, vehicles, and structures, for boats and ships, and windmill blades. Now, at the other end of the spectrum, in high-volume applications, the fiber reinforcement is compounded into the plastic and it flows in the mold to create the finished composite part. Such composites are a good choice and widely used as panels and secondary structures for automobiles and trucks, machine housings, and personal watercraft. These composites are quite stiff and have high heat resistance compared to unreinforced plastics, yet are low cost and can be produced in high volumes. These parts can be manufactured with a high level of part consolidation and detail, albeit with the penalty of lower strength. Compared to the pre-placed reinforcement composites, they have more variation in mechanical properties and do not use the reinforcement as efficiently as pre-placed composites. When SMC flows into some part details, the fibers align themselves with the direction of flow. The resulting laminate has mechanical properties that are much higher in the direction of flow, but much lower across the direction of flow. This can result in unexpectedly weak parts. Prime offers much greater uniformity of fiber placement, which helps not only mechanical properties, but cosmetic properties as well. It's perfect in the automotive industry for high-volume parts that require greater structural integrity than SMC provides. An ongoing challenge at MFG has been to combine the cost and volume benefits of a flowed compound with the structural efficiency offered by pre-placed reinforcement. In order to lower these costs, we needed a better means of preforming the reinforcement. One such technique is directed fiber preforming, which has been used here at MFG since the early 1950s. DFP is basically a process to create a fiber mat in the shape of the part to be molded. MFG, the largest DFP user in the world, decided to take on the challenge of improving the DFP process head-on and launched Project Falcon. Headed by the team at MFG Research, Project Falcon was mandated to seek out the greatest variables in the DFP process and find ways to reduce them. Sheet-molded composites are produced in a continuous process, and as such they have low cost and a high degree of uniformity. Preforms are produced in a batch process, and there's piece-to-piece variation and relatively high cost. The purpose of Project Falcon was to close the gap between the batch process and the continuous process. Project Falcon The project to deconstruct the preform process identified 4 areas for opportunity. One area dealt with the amount of thermal energy involved in the process. One dealt with the amount of mechanical energy required in the process. One dealt with the amount of labor in the process. And the final component was capital. How many parts were produced per dollar of investment? Project Falcon dealt with each one of those and found solutions that significantly lowered the cost in each area. They were finally reassembled, and the result is Prime. One key element of the enhancement of the DFP process is a change in the binder used to hold the fibers in place, from a thermosetting glue to a thermoplastic hot melt. This eliminates curing ovens and process time, and it increases the wettable surface of the fiber. With the thermoplastic hot melt process, the resin is molten for only a few seconds to wet and bind the fibers. Then it freezes almost immediately. The result is a finished preform ready to mold. MFG has dramatically improved the directed fiber preform process by reducing the variation in fiber placement and the labor content through the use of advanced robotics.
The robotics give us consistency, repeatability from part to part over the run during a shift, and then it's easy to then shift to another part that has been programmed to do that part. So we've taken the human error out, taken the operator that used to control this machine, and then have the operator now control the robot and program the robot. Our output has increased well over 50%, and our consistency has improved by over 100%.
As a result of the Project Falcon initiatives, MFG has achieved significant reduction of mechanical property variables in the directed fiber preform process. This has enabled design allowables to be raised and reduced process energy cost by 50%. You gotta love charts. First chart we're looking at plots impact energy for prime versus a sheet molded composite laminate. As you can see, at various stages of the impact event, prime absorbs far more energy than the sheet molded composite. Second chart I'd like to show is tensile strength and tensile modulus. Again, prime versus sheet molded composite. Note here that the averages are very close for both materials, but look at the range. The range is much tighter for the prime part. This is reflective of much more uniform distribution and orientation of the glass fibers. The lower variation means a higher design allowable for the prime laminate. Prime is just one part of MFG's 60-year love affair with fiberglass reinforced plastics, and it truly has been a labor of love, going all the way back to our founding days.
We've been in business since 1948, under the same ownership and family management. We have dedicated teammates, we have a great deal of experience. We have diversity so that we are able to do a whole variety of different things for customers, from very small quantities to very large quantities. MFG serves the automotive market, the truck market, transportation. We service renewable energy, both in wind and solar. We service military, construction, material handling, a whole variety of different industries using a prime process or one that uses pre-placed reinforcement. We're located in 10 different states and the country of Mexico, so geographically we're quite desirable. We have a good team that is very customer-oriented, and we strive on exceeding our customer expectations.
Prime is mainstream. Prime works. It's the solution for a broad range of high-volume commercial applications. Is Prime right for you? Contact us today to find out. MFG Value, offering our customers innovative choices and unmatched experience in the ever-changing world of composites.